Hi guys, welcome to my YouTube channel. My name is Michael Mwansaliova. I'm yet to present to you Calculus Part 1. The presentation outline will cover the following. I'll look at what a function is in this particular case for calculus. I'll also look at the single term differentiation function. I'll look at derived function or differential coefficient. I'll also look at basic forms of single term function of differentiation. So what is differentiation in the first place? Okay. It can be taken to be a process of finding the rate of change of a function with respect to its independent variable. Okay. Differentiation, particularly in calculus, is an important function, okay, which helps us to determine a number of ends. Okay. When you look at calculus, calculus in this particular respect is taken to be a study of continuous change. And calculus was taken from the exploits of the 17th century modern Latin coinage which is taken to be infinitesimus. Okay, an infinitesimal number is a quantity that is closer to zero than any standard real number. That's what is taken. Okay, so in this particular regard, we are looking at calculus as the study of continuous change. Just like we know that geometry is the study of shape, or algebra is the study of generalization of arithmetic operations. Okay, so let's go and run with this particular definition relating to differentiation. We start looking at what a function is. A function is made up of a composition of one or more terms which are differentiated term by term, which are connected to arithmetic signs of positive or negative. Okay, so that's what a function is. Okay, a term, on the other hand, can be taken to comprise of independent variables raised to an index or an exponent. And on the left side, you normally find a coefficient, which is a number without a variable, okay, which can be a positive or negative number. Okay, so we look at that in this manner. It can be expressed as a function. We have t is equal to cv raised to power I, where t is a term taken to be the term, and then we have c taken to be the coefficient, and v taken to be the variable, where I is taken to be the index or exponent. Okay, let's look at some of these examples of functions. So the function of x, the first one is telling you the function of x is equal to 4x raised to power 2. Okay, the next one is telling you the function of x is equal to 5x raised to power negative 2. The other example, the third one, is showing you that the function of x is equal to 4x raised to power negative half. Okay, so you should note very carefully in this particular regard that the term is actually a basic unit of differentiation of a function. Okay, let's move on to look at single term differentiation formula. Okay, in this particular regard, let function of a variable equal to coefficient of the variable raised to a particular index be one term function. Why is it one term function? Because we have only one variable in this particular case here. Okay, this means that differentiate the function with respect to independent variable to get a new function. Okay, so that's what it is. Differentiate the function with respect to independent variable to get a new function. So given as the derivative of a function is given as d function of the function over d of the variable. Okay, so that's how it is. So it can be written as d, then you start with the coefficient of a variable which is raised to a particular index over d of the variable. So when that is the process complete, it turns out in this last particular presentation. Okay, that's how we differentiate a single term function. So let's look at in this particular case what we are looking at, the derived function or differential coefficient. Okay, so once you have gotten rid of this particular process, you end up having what is known as derived function or differential coefficient. Basically, that's why I've said that it's a new function expression obtained after differentiation process is complete, and it's called derived function or differential coefficient. This is indicated by an apostrophe or a simple stroke or single stroke or double stroke, okay, at the top of the function letter, like we have indicated here, f raised power 1 or one stroke there equal to the function which has been differentiated. Okay, so a new function has been created. So that's what it is. So when you look at that, when you differentiate, normally you have to look at the exponent. The exponent has to be reduced by 1. As you indicate here, as indicated here, the exponent is reduced by 1, which means that you have made the first derivative. Okay. Then you have differentiation operator, okay, which is d by dx. So this is a mathematical symbol to show you that differentiation process has been performed on a function which give you differential coefficient. It's d by dx. Okay, so those are the terminologies that you should be familiar with. Okay, so then let's look at some of the basic forms of single term function of differentiation. So you can have, for instance, these four. Function of x is equal to x raised power n. Okay, or it is again written just as y is equal to x to the power n. Equally, you have number 2. We have function of x is equal to a, that's the coefficient, multiplied by x raised power n. Or simply y is equal to a times x raised power n. Or you can have the third one, which is function of x is equal to a multiplied by the root of x. Okay, the root of x, which can be written as y is equal to a multiplied by the root of x, nth root of x rather, nth root of x. Or you can have function of x is equal to a constant, okay, which is written y is equal to a. So these are the basic forms of single term function. Basic form of single term function. Okay, so now on this particular basic form of single term function, maybe let me look at a few examples that can be worked out using these particular basic forms of single term function. Okay, basic form of single term function. So let's look at a couple of examples that can be used. Okay, so I say example. Okay, example. Okay, for you. Okay, so let's look at first example. Okay, let me look at this one. Let's say we have this particular function. Okay, we have this particular function. Okay. Okay, fine. Okay, here we are. I want us to create something in the like. So let's say function of x is equal to, for argument's sake, we have say 6 raised power 4. Okay, 6 raised power 4. This is our first example. Let's see, how do we go about it? Okay, so if you are given this function, 6 raised power, well, let me just, this is x rather, x, okay, fine, power 4, that's better. So what we do in this particular case, look at this particular formula which I gave you here. So when you differentiate it, you have this x, okay, the index is reduced by 1, okay, the index is reduced by 1. So that's what we're going to do. We look at this one, okay. So what we're going to have is this one. So in this particular case, we have this 4, which is going to be reduced by 1. So we're going to have, in this particular case, okay, fine. Okay. Is it moving? Okay. Fine. So then, once we've got that one, it goes on to look at this one being basically, I want to get this one up here and this one. Okay, that much. Okay, so there we are. We have this part of presentation. Okay, so we have differentiated x with respect this function with respect to x. So that's what happens in this particular case. Okay, so we move on to look at another one. In this particular case, this one, number 2. How do we work out a function in this format, on this form? Okay, and to demonstrate again, this is say number 2. Okay, we are looking at an example in the form of that. Okay, we are looking at an example in this form. to be in this form. So now let's say that in this regard, this example has got something of this nature. Okay, we have something of this nature. Let's say here there is 5. Here there is say 3. Okay, so that's what we have. There's 3 there. Okay, what we do? How do you differentiate this one? So what we do is, okay, we look at this one. I'm going to say this one will become, okay, so like before, we bring down the power, so it will be 3, which is multiplied by 5, okay, which is raised to power. These are 3 we have in this particular regard. Just write it this way. Okay, this one comes down to 2 because you subtract it, reduce it by 1. So what are we going to have finally? We are going to have an answer in the form of, okay, an answer in the form of 3 times 5, which is 15. Okay, so this will be the answer. Okay, so in the first case we had this answer. Second case we have this answer. Okay, so that's how we deal with that type of a question or a situation when you are trying to actually see how we can differentiate it. Okay, that's how we differentiate this type of questions. Okay, that's how we differentiate this type of questions. Okay, yeah. Okay, so let's look at the other 2. We have this one. We pick it up from here. Suppose we have this type of function. How do we deal with it? Suppose we have this type of function. How do we deal with it? Okay, how do we deal with this type of function? So again, let me just insert a slide, so that we can start. That is number 3. Okay, number 3. So there we are. We have this type of a function. Okay, this type of a function. So what do we do? Let's look at an example I can look at, which is going to be used in this particular regard. Okay, let's say we have here a figure of say we have say 7. Okay, and then we have here we have say 4, and then the root of, let's say we have so let's say there's third. Okay, yeah. Okay, they can say third. Okay, so that's what it is. So when you have this type of arrangement, you say you have this. Okay, how do you solve this problem? Okay, how do you solve this problem? You come you convert it in this manner. You're going to say this is the same as 7, okay, multiplied by, okay, this is 4, that the third root of 4 is the same as saying 4 raised to power 1/3. So 4 raised to power 1/3. So let me just show you. Four raised to power 1/3. Power 1/3. Just want to pick that one. Okay. 4 raised to power 1/3. 4 raised to power 1/3. So I want this one. 3. Okay. So then that is going to give us that. Okay, so meaning, let's look at this. Okay, right. So here we have this thing 4, which is raised to power 1/3, which we are multiplying to 7. Okay, so that's what we have. So what happens in this particular case? Okay, say equals. So we bring down the power in front. So this is the 1/3, 1 divided by 3, which is going to be multiplied by 7, which is going to be multiplied by 4. Okay, multiplied by 4. And then we have 4 here, and then this is going to be the power of 4 is going to be reduced by 1. Okay, so if you have that, what are you going to have? So let's look at this. Okay, going to have this. Okay, let's put this way. Okay, we have that. In this part, we are saying reduce this by 1 as a power. Okay, so what are we going to end up with? What is the end product, or end result rather? The end result will be as follows. Okay, we have use the calculator. Okay, we have calculator. What we see, we have 7 divided by 3, which is that, then multiplied by 4, which is that. So we're going to have in this particular case the calculator saying 9.3, 9.3. Okay, then to which x is raised. Okay, this was x. We looked at this one as x, not okay, so no, this one was supposed to be x. Okay, even this one is supposed to be x. Okay, meaning this one also supposed to be x. Okay, but then this one, then we look, I'll get back to the calculator, is we have only so divide by 4 to reverse 2.3. Okay, 2.3. So 2.3, 2.33. Okay, and then x, which is raised to power, which we are getting here, okay, x. So when you remove 1/3, 1 from 1/3, what do we get? So let's look at this again. We have to clear this, we have 1 divided by 3 equals that, minus 1. What do you get? Okay, so that's what we have in this particular case. So to be negative 0.66. Okay, so in short, that's what we're going to have. Okay, negative 0.66. Okay, so that's is going to be the end result. That will be the end result. That will be the end result of this calculation. Okay, so that's how it is going to reflect as a final answer. Okay, okay, fine. That's the, what of the next one? This one. Okay, we're saying, how would it look? Okay, if we had to sort out a problem relating to that. Okay, let's look at this one. Okay, sort out a problem relating to this one. Okay, that will be number 4. Okay, let's see what happens. Okay, where you have a constant. Okay, in this case, what we're going to have is simply, for instance, the function that, and then you have say x, or no, you have a constant, say 6. Okay, so how do we go about it? So remember that is you have to differentiate with respect to x. There's no variable here, so that you are not differentiating with respect to any variable. So this means it's equal to 0. Okay. So that's how we come about this particular arrangement. So that ends this type of computation. That ends the type of computation we are looking at in this regard. Okay, so we end the computation we are looking at in this regard. So that is trying to demonstrate to you how we go about making this particular computation. Okay, so this is more of an introductory part. We'll look at these particular functions in a little bit more detail, and then we'll be very much comfortable dealing with them. Okay, so for this presentation, we come to the end. Just don't forget to subscribe to my channel to enjoy more presentations, and like my video. This one was a simplified one to help you cope with understanding how we go about this particular calculation.